Hello, Professor. Here will be my explaining walkthrough video of the code I wrote for the assignment 1 programming challenge. Um, the programming challenge assigned to me is to find all strings, give a BNF of type 2 grammar using 20 or fewer applications of the rules defined in the grammar. So let me firstly give an overview of the code logic and input-output form. So my program input will takes in two parameters. The first parameter is the BNF of type 2 grammar, and the second parameter is the limit number of applications of rules, which will be default 20 as stated in the requirement. The output is a string of white space separated terminal symbol strings defined in the grammar. My program logic overview. So my program will have 4 steps. The first step is it will read the grammar file given the grammar file path and turns all the rules into a key value pairs. And the second step is to randomly pick a starting rule. The third step is recursively calling a function to continuously generate the expansions until there will be no non-terminal symbols to be replaced. But there is a limit that if it reaches 20 applications of the rules, this program will stop. There's a very simple UI, which is basically using the print method to print out all the strings of terminal symbols that are generated from the program. So here, this is the a grammar file that I used for my testing and for my dev process. It has 10 defined rules that is type 2 grammar BNF form, or the left hand side is the non-terminal symbol within the brackets, and on the right hand side is either a non-terminal symbols that can continuously be replaced by the terminal symbols, which is basically English words here. Let's run the cell to overriding the grammar text file that I use in the dev process. Later on, we will use this file to test my program and show the result. I imported from a program. I imported two module, the random module and regex module. My program only have one entry function, which is called find strings. Takes in the first parameter is a grammar file path, and the second parameter is the limit. For this entry function, and call a bunch of other helper methods that are defined here after the entry function. So the first thing I wrote here is to initialize a state for storing all the data that will be produced by the recursive function, and to keep track of the execution counts of the recursive function. And the initial state is called final response. It has two attributes. The expansions attribute is a type of list/array. The second attribute is called count, which is a number type. And first of all, I called read grammar function that will turn the grammar rules into a rules map. The key value pair, for each key value pair, pair, the key is the left-hand side symbol, and the value is the right-hand side rules. After getting the rules map ready, I will call this pick random method, which is also a helper method here that takes in a list / array, return a randomly picked element from the list. So I call this method to randomly pick a starting rule from the rules map generated by reading the grammar file. And from passing the starting rule into the gen expansion function, which is a recursive function, it also takes in the initial state, final response dictionary / object, takes in the rules map dictionary, and also the limit number. And the final step use the print method to print the strings being pushed into the expansions list of the final response state dictionary. Let's take a deeper look at this gen expansion recursive function here. So for this recursive function, it has a if-else block. The if block is actually the checking, the type check to make sure it does not reach the limit. If it does not reach the limit, it will continuously run this block. So for this block, it also has an inside if-else block, another level, that it will firstly split the starting rule into a groups of rule by splitting the pipe pattern. It will call the pick random method again to randomly pick a group. So for example, if the starting rule for this grammar is starting from rule 2, it will randomly either pick this one or either pick this one. If it pick this one, this one, it will use the regex pattern to find all the brackets here, which will be a 3 elements array being converted from this group. And for each non-terminal symbol here, it will read the rule and to randomly pick, like continuously recursively pick the right-hand side group for each symbol here. That was an example of the logic of overview of this recursive function. So for this inner side if-else block, it uses has non-terminal symbol method to check if a has any non-terminal symbol. If it has, it will loop through the symbol and call the function itself. If it does not have any non-terminal symbol, it will reaches the else block, which will append the R group, which at this point will be a terminal symbol, which are basically English words defined in this example here. Yes, let's run the cell. get let's get put into the Jupyter notebook, define the function, and then here we can run this method a couple of times to see how many different results we can get. We get a web, which is yes defined in the last row here. We get the Jane subliminal ordered left green A. Oh, wept again. Spot died. I hope I can get a longer one. Then there we go. A big wonderful child hit Elmo. Oh, which is actually a meaningful sentence in English. Okay, so Professor, I'm going to link my video here after this cell, and also I put a reference here that I actually get a lot of inspiration, and also the example of the grammar for me for the testing, and Dev was also picked from this website. It's a Stanford University CS classes. They have quite useful resources hosted on the website. If you have time, you can take a look at this resource. And that's my walkthrough video here. Thank you so much. Thank you so much for watching this.